Hello everybody and welcome back. I'm going to apologize right now for this long introduction, but what I'm trying to do in this video is teach you software design at a very fundamental level. So I've heard you guys loud and clear. A lot of you are sick of the beginner tutorials, you're sick of people assuming you know nothing, and you want to get more into the intermediate and advanced level. You want to figure out, how do I design software? How do I look at some systems, some programming, come up with some kind of plan, some kind of implementation approach or strategy? That is exactly what I'm going to be showing you here. So on the left-hand side of my screen, you can see that we have this kind of mock software system that I've just come up with, this completely random example that I just wrote up before this video. And what we're going to be doing is looking at this block of text here, which you can really think of as the client. You can think of it as, this is what the client wants. This is what the person you're writing code for wants. How do you take simply these 4 paragraphs here and translate that into a fully functioning software system? That is exactly what we're going to be doing here. So we're going to look through this. We're going to go through the process of picking out valuable information, and then what we're going to do is actually draw up a class diagram that has what our plan is going to be when we start implementing this. And that leads me to my next point, which is planning. When you want to get out of that intermediate or you want to move from kind of intermediate to more advanced, you already know how to program. The next step is thinking about designing programs, designing software. It's not enough to be good at programming. What you need to do is actually be able to think about the kind of overarching architecture of the program that you're writing. You want to think of, okay, how are these objects, these classes, this system going to interact with other things, and how can I think about all of these things before I actually start writing code? That is what we're going to be doing here. So without further ado, let's go ahead and get started. I'm going to read through this design problem here. There will be a link in the description if you'd prefer to read through that yourself. And I would encourage all of you, before I go ahead and start doing all of this for you and showing it to you, that you think about how you might design something that looks like this. And if your immediate thought is, I have no idea, then well, this video is going to be perfect for you, because I'm going to show you exactly how we can do this. So let's go ahead and read through this. So the problem I've had here is design problem, Tech with Tim, School of Programmers. So I just kind of made this name up. I thought it would make sense. I assume a lot of you guys are students, or you were at one point a student, so I think this will relate to a lot of you. And the idea here is that the Tech with Tim School of Programmers needs a new system to track all of its students, professors, and courses. So think of this as some kind of like, mini university or something, and they want a system or a database or something like that where they can track all of this information. Maybe they can ask some type of questions about a student, they can check grades, they can see who's teaching a course. That's what this really is. So we'll go through the details here, but it wants to keep track of what courses are offered, who teaches each course, and which students are enrolled in those courses. It would also like to be able to track the grades of each of its students across all courses. For each student and professor, the school needs to know their address, phone number, and age. So immediately, even in just this first paragraph, this has told us a lot. We need a system, right? Because we're just thinking about what is it that we actually need from the system. These are really the requirements that are being listed out here. And this system needs to keep track of students, it needs to keep track of professors, and it needs to keep track of courses. What else does it need to keep track of? Well, for each person, we need their address, their phone number, their name, and their age. So let's keep that in mind. We'll read through the rest, and then we'll distill all of this. Okay, so each course has a maximum and minimum number of students that they can enroll. If the minimum number of students is not reached, then the course will be canceled. Each course is taught by at least one professor, but sometimes may be taught by many. So in some situations, there may be more than one professor that teaches the course. All right, professors are salaried employees at the Tech with Tim School of Programmers, and therefore we need to keep track of how much they make each year. If a professor teaches more than 4 courses in a semester, they are granted a one-time bonus of $20,000. All right, students can be both local or international students and full or part-time. A student is considered a part-time student if they are enrolled in less than 1 or 2 courses during any given semester. So actually, sorry, this should say if they are enrolled in 1 or 2 courses during any given semester. So essentially, you are part-time if you are taking 2 or less courses in a semester. The maximum amount of courses a student may be enrolled in at one time is 6. Students receive grades from each course. These grades are numeric and in the range of 0 to 100. Any students that have an above average grade across all enrolled courses that are lower than 60% is said to be on academic probation. So I apologize for butchering some of that speech there, but the idea here is we have this system. It's fairly simple. We need to keep track of students, professors, those students' grades across all of the courses. There's a few small nuances within that, but this should be something that we're going to be able to design, and hopefully in the next 30, 45 minutes with me explaining everything that I'm doing. So given this block, right, given this text, what we need to do now is translate this into a program. And the first thing that I want to do is start thinking about all the information that I actually need to track and all of the potential classes I'm going to have in my UML class diagram. So we're going to design this using an object-oriented style, which is very common and what most people kind of do. And this doesn't necessarily mean that what I'm going to design here will be the final implementation that we actually program up. This is just kind of the thing that is, our design. This is what we thought. This is our plan. It's totally fine if we decide to deviate from this later, especially if other things come up. But we should at least have some kind of idea of what we want to do. Then we can follow that when we actually start coding. So what I'm going to do is have two windows here, one on the left, one on the right, and I'm going to start listing, first of all of the classes that I think we should actually have based on the information I've seen here. And this is kind of the first step. Think about all of the objects you might have in a system, all of the main components that might have information within them. So the first thing I'm going to list here is students, right? We will probably have a student class because we're going to have multiple students. The next thing we're probably going to have is, professors. Now, I don't know if that's how you spell professors, but we'll put that there. So we're going to have a student class and a professor class because we're going to need both a student and a professor, and the student has different information contained in it than the professor does. Awesome. All right, so student, professor. Next thing we need is probably a course, right? We're going to have different courses. Those are going to be taught by professors, and those are going to be taught by students. And after reading this, not taught by students, sorry, students will be enrolled in that course. And after reading this first paragraph, that is kind of what I've grabbed from that. So I've said, okay, we need to keep track of students, professors, and courses. We need to see what courses are offered, who teaches the course, who's enrolled, keep track of grades. Okay, so that brings me to grades. So now I need to keep track of grades. How am I going to do that? Well, we'll keep moving and then we'll think about how that's going to happen. So each course has a maximum and minimum number of students they can enroll. If the minimum number of students is not reached, then that course will be canceled. Each course is taught by at least one professor, but sometimes taught by many. Okay, so that doesn't give me any more classes, I don't think, right now at least. And let's keep going. Professors are salaried employees at Tech with Tim School of Programmer, and therefore we need to keep track of how much they make a year. Okay, that doesn't say anything to me. Students can be both local or international. A student is considered a part-time student if they're enrolled in one or two courses during any given semester. Okay, and now after reading all of this, what I've determined is we have student, we have professor, we have course. The only thing we're really missing here is a way of keeping track of who is enrolled in what course and what grades each of these students have. So what I'm actually going to do is I'm going to make a class called enroll. Now this is going to seem weird, but what this enroll class is going to do for us, and it will make more sense as we go through this video, is essentially link our students and our courses. So essentially we have a way to say, okay, this course is taught by this professor and this student is enrolled in this course. The reason I want this enroll is because this enroll will essentially tell me, if, first of all, if this course is active, right? Is there enough people in this course that this enrollment was successful? That's something we could keep track of on the enroll class, and it can keep track of the grade that the student had in the course. We need some way to keep track of all of the grades for all of the courses for all of the students, and this enroll class could be a way to do this. Now keep in mind that I might change this as we go through, and as I start drawing things out, it might make more sense to do something else, but this is my initial idea, and this is where I'm starting from. This is my starting ground, and this is what I'm thinking about right now, and this is what you should think about when you are reading some requirements that look something like this. Okay, so I've settled on these 4 classes for right now. These could change. Again, I'm trying to walk you through the process as fully as we can so you really understand. And these are the 4 classes that I think I'm going to need. Student, professor, course, and this enroll one is going to link those courses and those students together and store some information in it, maybe like the date we enrolled in the course, something like that. Okay, so now that I have that, what I'm going to do is I'm going to spread these out, and I'm going to start listing information that I need to keep track of for students, professors, and so on. So now what I'm going to do is start looking at what information do I need for students. So down here it says a student can be both local or international, full or part-time. So the first thing I'm going to say is we'll say local, and that will be a Boolean value that's either going to be true or false. Is this student local or are they not? And in fact, what I actually might make this is just international. international. I think that's right. And this will just tell me if the student's international or not, and that will tell me if they're local, right? Because it's a true or false value. So we'll keep that as an attribute of my student class. That's some type of information we're going to need to know. And then it says the student can either be full or part-time. Okay, so we could consider that to be an attribute of the student, whether they're full or part-time, but how is that attribute derived? That is derived based on the number of courses that they're enrolled in during a given semester. So instead of making this an attribute, what I'm actually going to do is say, well, something that I need on my student is going to be a method, and the method is going to say is part-time. And this will simply return a Boolean. And what this will do is it will look at the student and tell me how many courses they're enrolled in. And if it is greater than the threshold of the part-time student, then they will not be a part-time student, right? That is what this method will do. So things that we start thinking about is how are we going to implement this kind of attribute? Well, we're going to do that using a method so we can determine if a student is full or part-time. Okay, so the maximum amount of courses a student may be enrolled in is 6. Students receive grades, okay. And then what else does it say here? If the average grade is lower than 60%, they're on academic probation. So this one is derived from their grades. So again, since it is a derived attribute, it's not simply just something that's going to sit there. What I need to do is have a method that tells me, hey, are they on probation? So we'll say is on probation, like that. All right, so we'll put that there, and then this will be Boolean. And what these methods are intending to do is to look at attributes on the student, evaluate them, and then give us an answer to give us these kind of attributes, right? Are they part-time or are they on probation? Okay, so now that we have that, let's move to professor. Don't worry, there's a lot more stuff that I'm going to add in here, but I want to talk about that later. So professor, what do we need here? Well, a professor, we need to keep track of their salaries. So first thing we'll say is salary, and this will be a number, right? Or an int or whatever you want to call it. Well, actually, it probably would be a float because they could have a decimal point salary. So we'll put a salary there. What else do we need for a professor? Well, there's nothing else on here that it really says we need other than their age, name, phone number, etc., which we'll get to in a second. So for that, I'm going to leave it there. Now, course. What do we need for a course? Well, it doesn't specifically say there's anything we really need for a course, but what I'm going to have for a course, of course, is the name. I'm going to have the course code because that's something that we're probably going to need. The name will be a string. The code will be a string as well, actually. And then what else do we need? We need the minimum and maximum amount of students in the course. We'll say min students. That'll be an int, and we'll say max students, and that will be an int. And then what I'm actually going to have is, well, we need to determine, is this course active or is it canceled? So is this going on? Do we have enough students in this course for it to happen? So what are we going to do? We're going to add a method that says is active, or we'll say is canceled, just because that goes more with the requirements that we had there. So we'll say is canceled, Boolean, and what this will do is look at all of the students enrolled in this course and tell us if there is enough so that it's canceled or it's not canceled, right? I hope that makes sense. Okay, so we have student, we have professor, we have course. Another thing that I'm thinking we might want to do is have something like the start time for this course. It doesn't necessarily say that we need that, but if I'm thinking about my program in the future, it probably makes sense to have something like start time, right? Like when did this course start? Well, you might want to keep track of that. So we'll say start, and we'll say that's a date, and then while we're at that, we might as well put an end as well, and we'll say that that's going to be a date too. So hopefully you get the idea that what I'm doing is just going through and picking out all the necessary information and just listing it out so I can see it before I actually start drawing anything. So we have student, professor, course, and then we have enroll. Okay, so enroll. What do I need for enroll? Well, this is going to keep track of how my students are enrolled in courses. So for enroll, what I'm going to do is I'm simply going to say date. So we'll literally say the date is going to be a date. So this is when this happened. So when did they enroll? We're going to need what student enrolled, what course enrolled, and then we're also going to need the grade that the student got in that course. This for me is pretty much going to keep track of, hey, this student is enrolled in this course, and this is the grade that they received in this course, and that will be a float. And then anything else that we might want to keep track of that's specific between a student and a course, but doesn't make sense to go in just the student or just the course, would be information we put in enroll. And for now, I don't think of anything, so I'm going to leave it like this, and this is kind of the core information I need, except for this address, phone number, name, and age. Now, the reason I've left this out is because these are going to require some more classes. Notice that for both a student and a professor, we have some shared functionality here, or we have some shared attributes. We have the address, the phone number, the name, and the age. So what I'm actually going to do is I'm going to make another class here. I'm going to call it person, and what this person class is going to represent is a base class for both the student and the professor. So the student and the professor have some shared things that we want to know about them, so let's put that into a base class that I'm going to call person. So inside of person, what I'm going to do here is I'm going to say, okay, what do we need? Well, we need the name, so actually we're going to have to say first name, oops, if we could type here, so first name, that'll be a string. We're going to say last name, that will be a string as well. What else do we need? We need the age of this person. So do I do age int like that? I'm going to ask you guys a question here. I can't really because it's not an interactive environment, but think about if this age makes sense to put here. Does it make sense to have an attribute called age? Because we want to keep track of the age, right? It says we need the age in this person class. So think about it for a second. Okay, I'm assuming you've thought about it, and I'm going to tell you right now that it makes no sense to put an attribute called age, which is an int. The reason you never put an attribute called age on something is because an age changes, and guess what? An age is derived from your birth date. So on the current date versus your birth date, that determines your age. So rather than keeping track of the age, we want to keep track of the date of birth, which will tell us the age, right? We can very easily find the age if we have the date of birth, so this is going to be a date. So that was a little bit of a trick I put in there just to see if I could fool you guys. Okay, next thing we need is a phone number. So we'll say phone number if we can do this like this. So phone number, and that is going to be a, what is this? I guess we could call it, I'm going to call it a string just because we could have like the +1 hyphen yada yada yada. There might be a specific attribute we could use for that, but a string, it's fine. I think you guys get that. All right, now we need the address. So what is an address comprised of, though, is my question here. Is address really an attribute that I can put? Can I just put address like that? Well, the answer is yes, you can do that. But what I usually like to do, just to make things easier for myself in the future, is make a separate class called address that stores all of the information in separate fields about the address. So this way, I can very easily grab information from the address. I can sort by people that are living in a certain area. It just makes things a lot easier, especially if you're thinking about a database structure in the future. If you have a bunch of attributes that could be squished in one, separate out into individual fields. So let's look at this. Address. What is an address? Well, we need a country. We need kind of a state or a province. I'll just call it a state, but like it could be a province. That might make more sense. We're going to need a street. We'll need a street number. So we could call this the street address, and that could be one thing. So we need country, state. We're going to need a city. We need the street address, and then we need a postal code or zip code or something like that. So let's just go postal code. Now these country, this is going to be a string. Almost all of these are going to be strings, actually. This is going to be a string. This is going to be a string. I think almost all of these are going to be strings, and the postal code will be a string as well. So go string, and street address needs to be one word. Okay, so now we have information related to an address. If we wanted to add some more information about address, like maybe you wanted to get really specific and go longitude, latitude, something like that, you could technically add that to this class. And now what we kind of have, and let me go over here and make this a bit bigger, is all of the information that we needed out of this problem right here. I've kind of taken it out, I've read through everything we needed to, and I've said the information I need to store is the following. I need an address that has all of this. I need a person that has all that. I need a student, a professor, a course, and an enroll class that stores the date and the grade. Awesome. Now the next thing to consider is what we call associations. So I've listed all the attributes specific to these classes, but these classes can associate with each other. In fact, the address is going to belong to a person, right? Each person needs to have an address. A student is going to be enrolled in a course through this enroll class. A professor is going to be teaching a course. So how do we go about and do that? Well, this is where we use associations. Now, associations are different from attributes. They are a way of linking two objects together. And the next part of what we're going to do here is pretty much determine how we want to associate all of these objects. And once we draw that out and we have the associations, don't be focused on the implementation in code, just be focused on how these objects interact with each other. Because if we can understand that, we can very easily implement that into code later on using whatever programming language we want. And that's why you'll notice, I'm not using str like I normally would in Python. I'm just writing things that are descriptive enough that anybody in any programming language could look at this and translate this into some kind of working implementation. So let's keep this on the side of our screen here. I'll make it a little bit smaller, and I'm going to pop up actually OneNote and start doing some drawing. So let me grab my drawing tablet and I'll be right back. Alright, so I've shut off my camera here just to give us the most amount of screen real estate as possible. And what I'm going to do is I'm going to start by apologizing for my drawing skills because they are very poor, but I'm actually going to draw what we've just kind of done on the left-hand side of the screen here and put it into a visual picture so we can actually see what's going on. So I want to draw all of these classes, and I'll tell you what all of the things that I'm drawing mean, and then what we'll do is actually link them up just using lines. So essentially I'm going to draw all these little boxes that look like this. I'm going to write here this is a person, and then I'll put in all of the associations for that person. Then we'll have another class over here, and what a line like this means is an association. So essentially this person interacts with this other class, and what we can do is put little numbers and symbols on this association to tell us what this association is. Is this a one-to-one association, which means one class links to one other class, or does this mean this one class could link to many other classes? Is there a limitation on the amount it can link to? Well, that's what we're going to put here. And the idea is that you can write two numbers. So if you write one number, what this states is that is the amount of associations. So when I write 1, this is saying that this person class, one of it can link to many, which is what the asterisk stands for, of whatever this class over here might be. If I write something like 1.2, so say, let's replace this with 1.2, what this means is that we could have 1 or 2 person classes. If I write 1 asterisk, this says the minimum we can have is 1. The maximum we can have is infinite. If I write just an asterisk, which is just my crappy star like this means we can have as many or as little of whatever is on this side as we want. So I hope that makes sense. It will make more sense as we go through this, but I just wanted to give you a little definition before we go too far. All right, so let's delete that. Let's get back into this. So the first class that I'm actually going to draw is my person class. Now remember, my person class is going to be a base class. So let me just up this pen size a little bit to make it a little bit easier. So let's draw a class like this. I'm going to try very hard to keep this neat enough that you can read, but it is hard to do with the drawing tablet. So we're going to say that's person, and what does a person have on it? First name, last name, date of birth, phone number. Now just to keep this video shorter, I'm going to avoid writing the actual type of what these are. So I'm not going to write string and all of that. I'm just going to write the actual name of the attribute. So we'll say here, this is first name. Okay. So when I do a little hyphen like this, what I'm saying is this is an attribute. So I'm essentially saying this is some piece of information that is contained within this class. So I'm saying first name, I'm going to say a last name like that. What else do we need? Date of birth. Okay. Date of birth. Next, we need a phone number. Okay, so let's go there. All right, I don't think that's too bad. I think you guys can kind of read that. So there we go. Person, first name, last name, date of birth, phone number. Okay, now this, remember, is the base class for my student and for my professor. So in order to illustrate that, what I'm going to do is I'm going to draw 2 more classes underneath this, and I'm going to show you kind of a fancy arrow that we can use to illustrate that this is a base class and this is a generalization. So I'm going to draw my 2 classes here. This is going to be one for my student. So we'll say, actually student will go on the other side, sorry. Actually, maybe not. Let's just leave student here. Student, and this will be professor, like that. Okay, so we have our student and we have our professor. Now let's write what we need inside of here. So for our professor, we just had the salary. And for our student, we had, what is it? International. Okay, so international. And then we had two methods on our student. Now, usually you do a method using a plus sign. What this says essentially is this is a public method. Everyone else can see this. There might be more methods on the student or on the professor in the future, but if they are not public, we don't write them down because we're just interested in what, all of these classes, how they're going to interact together and what they can see on each other. So we have student and we'll say is part-time, put some brackets, and we'll say on probation. I'm just going to write probation just to make it a little bit shorter. We'll write probation and we'll have two brackets. Again, if you can't read any of this, look on the side. That's why I typed it out. Now, to illustrate that these are actually going to be a generalization so that this is the base class for those two other classes, what you do is you simply do an arrow like this that is not filled in, and you just do a little line to these two classes. So what this says essentially is that this student and this professor are derived from this person class. So they are children class of this base class person. Now, what this means is essentially that they have all of these same attributes and functionality as this person class. So any associations that are made between person and some other class will apply to both of these classes because they are a generalization of this class. They are just a specific instance of a person, right? I hope that makes sense. So let's say we had a teaching assistant then. All we would do is just go like this, and now all we have to add is anything specific to the teaching assistant if we want them to be a derived class from person. So that is as easy as that is, and this is a very common thing when you're designing systems to have a base class that represents kind of the core functionality and then have specific instances or specific classes underneath that that have the additional functionality you need. So we have person, student, professor. What do we need next? We need an address. Now, who has an address? Well, a student and a professor both have an address. So what I'm going to do up here is I'm going to draw my address like this and just butcher all of this once again. Okay, so address like that, and let's go here and let's write what we need for the address. So we have a country. Okay, we have a city. We have a state, which I forgot. And then I'm just going to put ... You get the point. We have a street address and a postal code. I don't think I need to go through all of it. I think you guys get the point. Now, what I'm going to do is actually draw our first association. So what I just did down here is called a generalization. Now, that means that these things are not associated. They are actually like the same thing, right? Like a student is a person and a professor is a person. So that is why they are called a generalization when we do this kind of arrow like that. Now, what an association is a solid line between two classes that says, hey, every time I make one of these classes, I can potentially have this one linked up to it in some way. And now what I do is I define the multiplicity, is what it's called, of my association. So essentially, how many of these things can be associated together? Well, it turns out that one person can actually have multiple addresses, right? That is very possible that they have multiple addresses. So what I'm going to do is I'm going to say one person here, because an address can only belong to one person. We'll say one address is unique to one person, although in theory, that's not correct. You could have brothers or something that have the same address, but for our system, we're going to assume that this address object, maybe there'll be one that's exactly the same, that's totally fine, but they will only belong to one person. They will not be attached to two different people. In other words, we won't have person 1 here and person 2 here pointing to the same address. That won't ever happen. They will be two unique objects. So we're going to say 1, and then here I'm actually going to say asterisk. And what I'm going to do is say 1 ... which essentially says that one person must have at least one address, but they can have as many as they want. So the lower bound is 1, the upper bound is infinite, which means this person could have infinite amount of addresses. We don't know where they're going to live or how many addresses they have, and they have to have at least one, or they have to at least tell us about one for us to enter them into the system. So when you see something like this, this says that as soon as I make a person, I must create an address that is associated with that person. And same thing over here on address, this says whenever I make an address, I must have a person that is associated with that address. As easy as it is, that is the first association we needed. And in fact, we're actually getting close to finish this program. So we have our person, our student, our professor, and our address. The next thing we need is a course. Now, I'm running out of screen real estate a bit, so I'm going to just do the course over here, which is kind of on the edge of my drawing tablet, so it's hard to write accurately, but we'll write course. And then what do we have for a course? Well, we actually had a bunch. I'll just write a few of the straightforward ones here. So we had name, we had code, we had min. So I'm just going to short these, min, max, and then I'll just write, we had a start and end. I'll just write the method is canceled for now. But again, you guys get the point. That is the information we would have had. So is canceled with 2 brackets. Okay. Now, what do we need? Well, guess what? We have professors that are teaching courses. So we need to have an association between our professor and our course so that we know that this professor is teaching this course, right? So what I'm going to do is simply draw a line from professor to course. I'm going to say course, we'll put 1 like that. And then on professor, how many professors teach a course? Well, it said at least 1 professor teaches a course, but sometimes there may be many. So I'm going to write 1 ... asterisk like that, which essentially says 1 course is associated with 1 or many professors. And every time we make a professor, we must have it associated with a course. Wait, I don't know if that sounds correct. Whenever we have a professor, it must be teaching a course. That's not necessarily true. We could have a professor that doesn't teach a course. That is a possibility of our system. So what I'm going to do now is on course, go 0 ... 1, which essentially says we can have 1 professor teaching this course, but we also might not have any professor. Sorry, other way around. A professor might teach a course, but they also might not teach a course. And in fact, now that I'm looking at it, does only 1 course make sense? Because what this says then is a professor can only teach at most 1 course. No, that's actually wrong. So what I need to do is change this over here now to be a star, because it could have, a professor could be teaching a course, it could be teaching many courses, it might not be teaching any at all. So let's erase this and let's change this to a star. Now, I know that just was like a big, run around in circles of me doing everything except the right answer, but the point here is that that's what you want to think about. I'm bringing you through these scenarios so that you can understand how you approach a problem like this and how you think about those kind of edge cases. When you make your associations on here, you want to be very careful to design for flexibility. If you think the system in the future might do what you're limiting it to be able to do, maybe don't limit it to do that. It's better to have a system that is more flexible than to be super robust and super defined to the requirements, because the requirements do change, and part of designing is designing for scalability and flexibility. All right, so the next class we have is enroll, and this actually happens to be the last class, but this is actually one of the more complicated ones, and this is what I'm going to call an association class. So I'm going to draw it over here, and I'm going to call this enroll. So let's say enroll like that. And inside of here, we're going to have a date. And what else are we going to have? We're going to have the grade the student received from the course. Okay, so this is going to be what we call an association class. Now, an association class is a little bit different than a regular class because what it does is link 2 other classes together, which means this never exists on its own. It always has an association between a course and a student, and the whole point of it is to link a course and a student together. So we draw it a little bit differently than we draw most regular classes. So what I'm going to do here is draw an association between my student and my course. It's getting a little bit messy now, I apologize for that, but we do have an association now between the student and the course. And let's pick the multiplicity, and then we'll talk about how enroll actually operates here. So the multiplicity could be that a student can be enrolled in multiple courses, and a course can have multiple students in it. So what I'm going to say here is, first of all, on this side, we're going to put many, because a course can have many students enrolled in it. It might have 0, it might have infinite, right? It might have maximum. Then what we need to have next is, okay, well, how many courses can a student be enrolled in? Well, they can be enrolled in 0, so they could technically be enrolled in 0 courses. Let me redraw that because I kind of butchered it. And a maximum is 6. So the maximum amount of courses they can be enrolled in is 6. So essentially what I've said is that the lower bound is 0, the maximum is 6, which means they can be in any range in between that. And based on the amount of courses they're enrolled in, well, that is going to tell us if they are part-time or if they are full-time, right? That is how we're going to derive that. Now, this is where the association class comes in. So what I'm actually going to do is draw a dotted line, and I'll redraw that again just to make it more clear actually over here, between this association and the enroll class. what this says is this association is really enroll hitting course and student hitting enroll, right? So this is just like this enroll class has an association between course and student, and we use that to be able to determine what courses a student is enrolled in. That is the idea behind this intermediate class. It stores an association with course, it stores an association with student, and then it also stores some attributes on it that are very useful. For example, date. This tells us that whenever we create an association between student and course, we must pick a date that this happened at. So we know when the student enrolled in this course, right? That makes a lot of sense. And you could now determine, say, if a student was late to enroll in the course, because on course, if you look over here, we have the start and the end date, left-hand side of my screen, and we can compare the date that they enrolled in to the start and the end date. Then we have grade. Well, that tells us what grade they got in this enrolled course. And since there's an association between course and enroll and student and enroll, what we can actually have is we can have the professor update the grade of a student. So think about how this works, right? If I need to update the grade of a student, well, the professor has an association to course, the course has an association to enroll, and enroll has an association to all of the students, right? So in this way, what I can do is I can have the professor look at the course, look at all of the students enrolled, and then go into this enroll class and modify the grade. This way, the professor does not actually get to look at any of the personal information of the student to upgrade its grade. All it has to do is look at this enroll association class and say, hey, all I need to do here is change the grade. And then that will automatically update for the course and for the student. And what's great about this is, well, since every single student is associated to the course with an enroll class, if I wanted to do something like get the average grade of the course, all I would do is look at all the associations between student and one specific course, look at that enroll class, and then grab all of those grades. So this is the kind of system that I designed and that we were trying to design from the beginning. Something that is flexible and that can do a bunch of operations that may not have been defined yet, but that we probably want to do in the future. So that is pretty much it for this design. I need to erase this one line here. I don't think that was supposed to be there. But this is our finalized design. And I apologize that it is super messy, but the point of this video is not to be like, the most perfect, the most robust. It's to teach you the process of looking at a software system and designing it from the ground up. Starting from scratch, extracting the necessary information, translating that information, and then drawing a somewhat, kind of plan, drawing a design that we can actually go ahead now and implement. Because if you think about it now, all you have to do if you want to make this system is look at this and start implementing what I've defined. And if you actually look at this, it's not very complicated, right? We've broken everything down into classes, which you can write. We've broken it down into methods, and we've broken it down into attributes. So you don't even really have to think now when you go about programming this. You just have to look at this design and follow it, and if there's something that needs to be changed, make that change accordingly, right? If we want to implement person, all I do is make a class called person, add a constructor that has these 4 arguments, and there we go. I've made person. All right, I want student and professor. Let's have them extend the person class. Let's go, okay, add an international attribute, add these 2 methods, is part-time, is on probation. Professor, let's add a salary. There we go. Oh, associations. Okay, great. Let's handle these associations. Let's make a private field in each of these that stores the association between address or something like that, right? And that is as easy as it is to do. Now, the last thing I will say here, just because some people might be confused on how these associations are implemented, when you have a one-to-one association, you can think of that just like another attribute. So let me actually, I don't want to erase all of this, but let me just do something like up here in this little area. Essentially, let's say person has a one-to-one association with address. So imagine that this is actually 1. What that means is on the person class, we have another attribute called address. I don't need to write it because the associations infer that. And what this is really equal to is an address object, right? It's equal to some instance of address. And then that way, if I want to access the address of a person, I just call person.address. Now, this is the exact same thing on address. So let me erase this. If this is one-to-one, then on side of address, right, this has an attribute that says person. So this just says person, right? And then it points to a person object. And there you go. That way, the address, if it wanted to see the person, it could. If the person wants to see the address, they can, right? That is how a one-to-one association happens. Now, sometimes you might not store it on the address side. It really depends. But now let's say we have this one-to-many, right? Then what we would do is on here, we'd have another attribute. It would be called addresses, like that. And it would just be equal to a list that stored all of the addresses inside of it. That's as easy as it is. And that is what I'm talking about when I say association. It's just a link between these two objects. You implement that link however you want, but usually it's done just with another attribute or with something in the actual class itself. And that is how you can link these different things together. So with that being said, that has been this video. I know this is not, the most, I don't want to say educational, but this is really just the way of teaching you about how to think about this. It's just the way of training your brain to look at information, break it down, and throw it into some kind of design that you can then go ahead and implement. So like I said at the beginning, if you want to see the code for this, leave a like, subscribe to the channel, comment, spam me, let me know, and I will try my best to make a video where we implement this exact design. So that being said, I hope you enjoyed. If you did, leave a like, subscribe, and I will see you in the next YouTube video.